Welcome to Correlation. I'm on the scatterplots page. I'd like to get the well-being and body satisfaction data. So I scroll over here and click, and there I have the well-being and body satisfaction data set for 106 students. Each dot is a person, and so this dot, for example, is a person who has body satisfaction at 4 but very low well-being, down at 1. Overall, there's a broadly positive correlation between the two variables. In fact, we measure R, Pearson R correlation at 0.47. R can range from +1 to -1, with 0 being no correlation at all. And here we've got moderate positive correlation. So in general, well-being scores and body satisfaction scores, high go together, low go together, but with lots of scatter. It's good to think of vertical slices and horizontal slices through this distribution. So people who have body satisfaction of 3, well, they can range in well-being from down 2.5 all the way up to 6. And similarly, well-being 5 can range in body satisfaction from 2 up to 5 or so. Let's now go to CR to see what different values of correlation typically look like in scatterplots. The scatterplot is a wonderfully revealing picture of correlation. I've chosen n equals 50 for no very good reason. And first I'll use this slider to come up here to a correlation of +1, and there it is, a perfect positive correlation between y and x. You can think of these as 50 people and body satisfaction and well-being scores, if you like, or any other two variables measured for these 50 people. R equals 1, very tight to a line. Let's look at 0.9, and here's a randomly generated data set with the constraint that the correlation in these data points is 0.9. So again, we've got a very strong linear trend, a very strong positive relationship, but a little bit of scatter. Come down to R.8, and similar but more scatter. You see the picture. 0.7, 0.6, it's less clear. Well, it's a pretty positive correlation there, isn't it? 0.5, again, we can see a positive relationship. 0.4. By the time we get down to about these values, it's not quite so immediately clear we have a positive correlation. And when we're down to 0.3 or 0.2, the dots typically look much more like a shotgun blast, like a sort of random scatter of shotgun pellets around a target. Come down to 0.1, very weak positive correlation. 0, absolutely no correlation. And we can keep going. A negative correlation, -0.1, -0.2, -0.3, -0.4. And as we get further down, we begin to see the negative relation becomes more clearly visible. -0.5, -0.6, -0.7. By now it's extremely clear. Still scatter about the line, -0.8, -0.9, and -1, very tight to a line. Now let's choose just a medium correlation, 0.4, shall we say? A small to medium positive correlation here. If I click New Dataset, I'll keep getting new data sets that are random, except that they all have a correlation of 0.4. The point here is that for a particular value of R, the scatter can take many appearances. Doesn't the appearance really vary? And that's sampling variability, which we've become familiar with in numerous different settings. Now, next thing I'd like to talk about is eyeballing from the scatterplot. So I can turn off the displayed value up there. Don't look over here. And if I set this to some value, say there, well, what does that look like to you? Clearly positive, moderate amount of scatter, maybe around 0.6. In fact, it's 0.63. If I give you another one, say there, clearly a stronger positive correlation. And for values of about 0.7 or greater, 0.6, 0.7 or greater, it's good to think of how tight are the points to the obvious sort of line through it, the eyeballed line. And here's moderately tight, and we've got a correlation of about 0.9. But once we get down to smaller values, this is 0.34, then you can see a positive correlation, but it doesn't really look as though it's fitting a line very well, does it? But if we put a cross through, this is a crosshairs through the mean of x there and the mean of y there. Now look at the four quadrants. We can call top right and bottom left the matching quadrants, because here we've got a positive deviation of x from the mean and also positive deviation of y. And down here, negative deviation of x, negative deviation of y. So here we've got matching, positive, positive, negative, negative. And these are the mismatching quadrants. So what we do is eyeball roughly the number of points in the matching quadrants, that's top right, bottom left, and compare with number in the mismatching quadrants. We can weight it a bit by how far out into the quadrant the different points are. This is a positive correlation because there look to be rather more points in top right and bottom left, particularly if we allow for some extreme points, compared with these other two. So sometimes seeing let me give you another one. How about that? So here we've got relatively few points in the matching quadrants, quite a few more in the mismatching, and they're further out. So I'm going to say this is a moderate negative correlation, maybe minus 0.5, 0.4, and it's minus 0.41. There it is. So turning on or eyeballing the cross can be very helpful in estimating what a value of R is from a scatter plot. Do you think it's easier to eyeball minus 0.4 there compared with there? Well, you can use this CR page to practice doing that. Now I'd like to go back to scatter plots and look at our data set here and illustrate one more point. Here we've got correlation of 0.47, so moderately positive. If you like, you can eyeball a line and think about tightness to that line. Now I'm talking about tightness to the line, not slope of the line, because when we've got original units measurements here, as we have with well-being and body satisfaction, then the slope of the line we can change very easily just by changing the scale. So if I change this horizontal axis here to be from 2 to 5 instead of from 0 to 6, then I've got the same points, the same correlation, and an eyeballed line that's much lower in gradient. If I go back to the original, there we have the horizontal body satisfaction axis plotted from 0 to 6, and I've got a pretty steep eyeballed line through it. If I change that scale again to 2 to 5, I get a much less steep line eyeballed through it. So when we're eyeballing, when we're estimating from scatter plots what a correlation is, the relevant thing is the tightness of these points to a line, not the slope of the line. So you can play yourself a game generating scatter plots with any chosen correlation you like and try your friends and see how well they go at estimating what the correlation is. And you might find it helpful to think in terms of tightness to the line for very large values of R or moderately large values like this, that's 0.79, and the cross through the means and looking at the matched versus mismatched quadrants to help you eyeball correlations that are just moderate in either direction.